For our presentation on Luquillo Education Outreach, we will be highlighting our K-12 work under the umbrella of the Schoolyard Lter program. Much of our outreach focuses on engaging students with the core Luquillo phenomena, namely hurricane disturbance and drought. Along with our Lter logo, we highlight our Luquillo Schoolyard logo, which was developed by one of our Schoolyard students. Here is our current Schoolyard team. We have team members from the Learning Partnership based in Chicago, UPR, Turk based in Cambridge, Massachusetts, and Forward Learning in Guaynabo, Puerto Rico. This year, we have added 5 scientific mentors. You may notice that this is way more than our $27,000 of annual Schoolyard funding could support. During LTER 6, we've received over $4 million of leverage funding. We've received 2 DRK-12 grants, 1 iTest grant, a grant from the Battelle Foundation, they run NEON, the RET program, and fellowship support from EDI. Our overarching goal with the Luquillo Schoolyard program is to engage students in Luquillo science. Before we describe our Schoolyard model, it is important to get a sense of the context of the program over the last several years. In addition to the pandemic that everyone has been dealing with, the Puerto Rican school system has had to deal with Hurricane Maria that wiped out almost an entire school year since there was no electricity for 11 months. The southern part of the island had earthquakes in 2019. The earthquakes destroyed a beautiful geologic feature. Some schools are still closed due to structural damage. Puerto Rico's finances are managed by a congressionally appointed board. Education funding has been slashed. Our colleague wrote an editorial in Science magazine about the devastating effects to the University of Puerto Rico. School teachers are also feeling the pinch and went on strike recently. There's also a huge amount of teacher flight to the mainland. We need a new vision to avoid a lost generation of scientists. Our goal is to bring our programs together to build pathways that support students in becoming scientists. We seek to engage students in Luquillo science as junior members of the community. We use Levin-Wenger's legitimate peripheral participation framework as our framing for how to engage students as junior members of the Luquillo Lter scientific community. These first 3 principles of engaging students in authentic practices, using the tools and the language of the community, suggest the idea that students are legitimate participants in the practices of Luquillo science. The last 2 principles highlight that students are at the periphery of the community. They are not contributing to Luquillo science. Levin-Wenger characterized learning as movement from the periphery of a community to becoming a central member of the community. It is imperative to support the development of student identity as a member of the community. Our prior research suggests that engaging students as legitimate peripheral participants leads to greater interest in pursuing ecology. Through their research on apprenticeships, Levin-Wenger found an interesting pattern in terms of learning sequences. It is common in apprenticeship settings that the apprentices learn a process in the opposite order in which it is practiced. This view of learning sequences in the opposite order in which they are practiced is helping us think about how to organize our resources into a pathway. We're happy to announce that our children's book should be coming out this fall. Puerto Rico y el Poderoso Huracán, or Puerto Rico and the Mighty Hurricane, is about the resilience of El Yunque and the Puerto Rican people. This will serve as a motivator of interest in Luquillo research for upper elementary students. Next, we have Journey to El Yunque, where middle school students use models to explain population dynamics. Next is Data Jam, where middle and high school students now add on the practice of data analysis. And lastly, high school students are given an opportunity to come to El Yunque to engage in fieldwork. Our protocols work has been put on hold during the pandemic. We highlight the Luquillo process of inquiry and then highlight how the pathway builds those practices in the opposite order. We start with Journey Tel Jonke, which focuses on the end of the investigation process with using models to develop a scientific argument. One of the primary research questions for Luquillo ecologists is that organisms in El Yunque seem to be well adapted to hurricanes, but what will happen to the ecosystem if severe hurricanes strike the rainforest more frequently? This is also the overarching question students investigate in Journey Tel Yunque. From the overarching question, students delve into the dynamics of specific species, which mimics the specializations of Luquillo ecologists. Here we provide an example of the investigation of the population dynamics of the coqui frog. Students are guided through a process of inquiry that starts with the background readings about the coqui. We set up the readings in a narrative format to make them more engaging for students. Our prior research has shown that students do find the readings engaging. Their ability to extract the key concepts from the narrative format is equivalent to an expository format. We also limited the complexity to a 5th grade reading level to accommodate low readers. The most important reading is the interview with real estate Carmen Coqui. From her, we learned that the coqui needs leaves and other debris to hide their eggs since they are a tree frog. This provides an important clue about what might happen to the frogs after a hurricane deposits literally tons of debris on the forest floor. Now we will jump to the culminating activity in which students attempt to model how the limiting factors of the coqui may have changed after a hurricane to explain how the coqui responded. When students run the disturbance model, the green line represents actual data collected in the 5 years after Hurricane Hugo. The blue line represents the output of a coqui population model developed by Jess Zimmerman. The parameters for the limiting factors are initially set to the normal conditions. As a student, I can try to set the parameters to what I think happened after a hurricane. My notes from the background readings give clues on how to set the parameters. Perhaps the significant increase in the coqui population came about because there's a lot more food and there's a lot more hurricane debris. When I run the model again, I see the model gets very close to the actual data. It will never match exactly. For my final argument, I can use these model settings as evidence for how the changed environment after a hurricane affected the coqui population dynamics. Last month, at the annual meeting of the National Association of Research and Science Teaching, we presented research on the implementation of Journey Tel Yunque. We began the study in the school year following Hurricane Maria. We hosted a one-day workshop for 22 teachers. Given the instability of the internet, we provided teachers the website on a thumb drive in case their internet was not working. 10 resilient teachers were able to overcome their conditions and implement Journey Tel Yunque with 183 students. The teachers spent 1 to 2 weeks implementing the coqui unit. 90% of the students were Puerto Rican, and about 2/3 were female. Our gender data is consistent with a persistent cultural issue in Puerto Rico in that boys are dropping out as early as middle school to begin working and supporting their family. There were 2 primary instruments we used for this study. The first instrument is an adapted version of the University of Chicago inquiry-based science instruction scale. We sought to measure the extent to which students were engaged in the practices of science. At the end of the unit, students rated how often they used laboratory equipment, wrote lab reports, generated hypotheses, used evidence to support an explanation or argument, found information from graphs or tables, used a model as evidence for an explanation or argument, or created their own graphs. The scale ranged from not at all to almost every day. The second instrument was a pre and post assessment. We assembled the assessment using a collection of state standardized assessment questions related to population dynamics. The items clustered into 2 levels. At the basic level, students had to reason about changes based on direct links. In this case, the change in mouse population is explained by change in the mouse's predator. At the complex level, students had to account for the whole system to reason about changes. In this case, the students had to account for the fact that grasshoppers and crickets had another source of food, so they would be less affected by the loss of corn and oats, since that is the only source of food for mice and rats. We scale the items using a technique called Roche modeling. This process measures the ability level of students using the same scale as the difficulty level of the questions, so that you can compare the two. The process confirmed that the basic items were easier than the complex items. The assessment scale ranged from 0 to 10. The first thing to notice about the average pretest score is that the majority of students are able to reason about complex ecological relationships like those found in Journey to Yonke. All too often, we see middle school ecology curricula that overemphasize basic relationships when most middle school students are ready to reason about complex relationships. We also administered the same assessment as a post-test and saw a small statistically significant increase with an effect size of 0.2. The small size of the increase is expected given the short length of the unit and the distant nature of the assessment questions. We then aggregated this inquiry-based science instruction scale at the classroom level and conducted multi-level modeling to correlate the inquiry-based science instruction scale with the post-test score controlling for the pretest score. We found a statistically significant correlation. These results are consistent with Levin Wenger's contention that all learning is enculturation into a community of practice. It is a matter of discerning which community students are being enculturated into. Are students being enculturated into the community of educated adults in which the focus is on certifying completion of coursework, or is the focus on enculturating students into the Luquillo ecological community by focusing on engaging students in the practices of Luquillo science? It turns out the latter is correlated with higher outcomes on standardized assessments. The next program in our learning sequence is Data Jam. We've added an additional step in the inquiry process of students analyzing their own data. I will turn it over to Noelia to describe the Data Jam program.
Thank you, Stephen, for taking us on a journey through all the elements of our program and presenting about how they fit together into a greater vision. Now I'm going to focus on describing the Data Jam efforts, an element of the Schoolyard program where we have oriented our energy since 2015. From the beginning, we saw the huge potential in Data Jam as a mechanism that will enhance teachers' and students' ability in improving data literacy skills such as data visualization and analysis by the process of working with long-term data sets. We also recognize Data Jam as an opportunity to increase the numbers of schools participating in our program. By conducting Data Jam, students propose ecological research questions based on real science from programs such as the Luquillo Lter, Luquillo Critical Zone Observatory, and the National Ecological Observatory Network. The data origins are primarily from a Yunque National Forest and provide information about climatological disturbance such as hurricane and drought. Students use scientific tools to analyze the data sets used. The specific scientific tool that students use is the Common Online Data Analysis Platform, CODAP, a visualization tool designed by the Concord Consortium. After students complete their analysis, they create a final project. Here we show an example of students' Data Jam project in a poster format. The students present the result of their investigation at annual symposia, and some of these efforts are done in collaboration with other LTER sites. Most recently, we were awarded a National Science Foundation Innovative Technology Experience for Student and Teachers Grant, ITES for short. The project derived from this grant will focus on research and development for a new professional development model to support teachers in engaging middle and high school students in independent data analysis research projects using local ecological data. This project built on the foundation of the DataJam model. To help us understand how this project will contribute and enhance the DataJam strategies, it is important to describe the old mother scenario and how it was adapted. The old mother was implemented since 2015 to 2020 and consists of the following sequence of activities. First, a one-day teacher-only workshop of 5 hours prior to implementation with students, a half-day professional development for teachers and students in which students receive feedback on the research question and data analysis and learn the basics of preparing a scientific poster presentation. This all culminates in the student symposium at the end of the semester. Now, the changes and modifications for the new professional model, which was first implemented in 2021, consists of a summer 5-day teacher workshop with total of 30 hours before classroom implementation. Last summer, 15 teachers participated in the summer workshop. We host the workshop at facilities of the Forward Learning Company, a long-term collaborator of DataJam and Luquillo Schoolyard. The summer workshop activity of the new model were designed around a data attribute framework defined by Andy Rubin, our data expert from Lter. The framework focused on the following elements: distributional thinking and variability, data moves, attention to aggregate measures and individual cases, research question, and communicating research findings. The conceptual activities consist of an introduction to CODAP facilitated by the use of the challenge card, a scaffolding tool designed to help the teachers navigate the CODAP platform, and the See It and Now Make It activity to conduct data exploration and modeling. The challenge card also become a reference tool for teachers to use as they might face any difficulties while working on the See It, Now Make It activity. The practice activities include the challenge card to understand phenomena such as drought and the selection of a data set on shrimp or hydrology to develop a DataJam project. And to conclude the summer workshop, the teachers present the DataJam project they have developed, receiving feedback from scientific mentors, including Luquillo scientists and other collaborators, and other participating peers, and discussing the next steps toward the implementation process. The implementation process occurred during the fall semester. 12 teachers implemented this year. There were 3 mentor-teacher virtual lab meetings, each one ranging from an hour to an hour and a half. The group composition include 1 mentor, 1 experienced teacher from previous DataJam projects, 2 novice teachers, and 2 members of the DataJam staff. Each encounter was preceded by a support ticket, a form for teachers to communicate about their progress, status of the implementation, and raise questions or present difficulties prior to the next meeting with their mentors. Data staff facilitate the meeting following a protocol to guarantee equal amount of time for each teacher to express about the status of the implementation process and receive feedback from mentors and other teachers. Midway through this process, mentors presented to teachers and students about their journey of becoming a scientist and some of their research interests. This opportunity serves as inspiration for students to explore options in a STEM career path, as well as a space for students to communicate with the scientists and clarify questions about their DataJam projects. During this exchange, the students expressed their excitement about meeting a real-life scientist. The interaction also helped humanize the scientists and make a tangible experience for students to see themselves considering a future career track in science. The student has then the opportunity to finish their project and share their findings at the Student Symposium celebrated in March of 2022. It was conducted in a virtual format due to the pandemic, but it is intended to be in person next year. 46 projects and over 100 students presented their Data Jam project, which is a record in our Data Jam efforts. And now, Stephen will continue with our conversation.
For the last program in our Luquillo learning sequence, we turn to our protocols program. Students are given the opportunity to come to El Yunque, and we add on the process of fieldwork. So now the students are engaged in the full process of science. As mentioned earlier, this program has been suspended during the pandemic. Prior to the pandemic, those students who completed Data Jam were given the opportunity to come to El Yunque and conduct fieldwork in a plot in El Verde set aside for the Schoolyard program. Students collected vegetation data. The cool thing about the vegetation fieldwork is that we adapted the Luquillo Hurricane Damage Assessment Protocol. Students conducted a damage assessment of the demonstration plot after Hurricane Maria using that protocol. We hope to start up again to give students the opportunity to track successional changes. Students also collect stream ecology data, and they also collect soil data. In order for our Pathways vision to come to fruition, we need to build teacher capacity. At the moment, Data Jam is our main source of teacher capacity building. Prior to the pandemic, we found that teachers who successfully completed Data Jam were in a position to support students and engaging in our field protocols work. We have a cadre of teachers who are veteran Data Jam teachers and have implemented the field protocols program. Over the last 2 years, we have engaged 2 of those teachers in the Research Experiences for Teachers program, in which they're mentored by Luquillo scientists to conduct secondary analyses of Luquillo data. The resulting data sets that they created are fed into the Data Jam program as additional data sets for students. In addition, this summer we'll be hosting a University of Puerto Rico graduate student as a summer fellow funded by EDI. She will be creating additional data sets for the Data Jam program. Thus far, we have highlighted the pieces of the Luquillo Schoolyard LTR program and have provided a vision for how we will be working to build those pieces into pathways to set Puerto Rican students on a path to becoming Luquillo ecologists. For this school year, we highlight the reach of our Data Jam program. Despite all the obstacles, we're able to implement our Data Jam this year with 12 teachers at 10 schools, reaching 365 students. You'll notice that all of the schools are in the Northeast. This summer, we'll be hosting the workshop on the South Side to hopefully attract teachers from other parts of the island. Our goal is to double the number of teachers, schools, and students involved in Data Jam and to restart the field protocols work. We are currently seeking additional funding to rebuild support for implementation of Journey to El Yunque in Puerto Rico. We hope you see that the annual Schoolyard funding has provided a solid foundation and launching off point for the development of our Luquillo Ecology Pathways program.